Okay, so today we're graphing radical functions like square root functions. So we're going to start with the parent graph. This is the one that you look to. If you have this one memorized, and you really only need about 3 or 4 points that you need to memorize, it's really going to help you going forward for graphing these because transformations work the same for all functions pretty much. So let's just plot a few points here. So I'm going to plug in -4, -2, -1. 0, 1, 4, and 9. Okay, let's plug in 0 first. It's easy. So square root of 0. I'm just plugging in for x there. So if x is 0, you get square root of 0, which is 0. So 0, 0 is a point in this graph. I'm going to make it in blue. Square root of 1 is 1. So 1, 1 is a point on this graph. Those are easy points to remember. A lot of our parent graphs have those same 2 points. Square root of 4 is 2. So that's a little different. With a parabola, it's 2, 4, but with a radical or a square root of function, this is 4, 2. That's interesting. 9. I picked 9 and 4 because they're nice square roots. So square root of 9 is 3. I didn't have to read decimals. So 9, 3. It looks like the right-hand side of this graph is doing this. And it is like going through those points. Very nice. Let's plug in square root of -1 here. So if I plug in x is -1, that's I, which I can't really graph I over there, right? If I take square root of -2, I get I root 2. I can't really graph that. Square root of -4 is 2I. I can't really graph that. We don't have, these are x's and y's. There's no imaginary numbers on here, so it's not something we can graph. In fact, when you plug in a negative number, there is no graph for this function. So the domain, if you want to think about the domain for this function, it's x greater than or equal to 0. And in fact, the range, which are the y values, is y greater than or equal to 0. You don't have any negative numbers here at all. It starts at 0, 0, goes up and to the right. Both x and y are increasing forever. And so this is what the graph looks like. There is no negative. You can't plug in negatives to this function. You don't have any real answers there. So going back to that, so just so you know, so that if I said graph y equals square root of x, I would expect you to at least know these 3 points, 0, 0, 1, 1, 4, 2. The graph kind of looks like that. If you graphed it like that, that's pretty solid, right? The parent function, so the function, think about the one we know. This is the one we know. Let's compare it to that one. So this is the one we've used a lot this year, parabolas. The function looks like that. Now, I think you're going to notice for this function has a similar equation. I want you to write it down. Y equals a, instead of parentheses x minus h squared, it's square root of x minus h. So in a sense, inside the parentheses is still x minus h plus k. So this is the formula for square root. It doesn't have a square in there, it's just a square root. So the square root, symbol, it's what's inside of there is the x minus h. And so similar to what you've learned before, the h moves things right and left, k moves things up and down. A can be a couple things. If it's negative, it's going to reflect across the x-axis. If a is bigger than 1, it's going to be a vertical stretch. It's going to pull it up. If a is smaller than 1, it's vertical shrink or compression. Okay, so what do you think is happening here? If you look at that formula, the plus k is off to the side, is after the function, and that does seem to be after it. So this is going to move everything up 2 units. So let's start with the points we know and love, 0, 0, 1, 1, 4, 2. Move all 3 points up 2 units. So that one moves up 2, that moves up 2, that moves up 2, and my graph is going to look like this. The domain, if you wanted to ask, is x greater than or equal to 0. The range is y greater than or equal to 2. Okay, let's start with the original function. So let's see, this one's going to move it to the left 3 units because, again, it's x minus h, so x minus -3. So it goes the opposite of what you think inside the parentheses. You have to think of that as inside the parentheses. So you take the points we know and love, 0, 0, 1, 1, 4, 2. And every point is going to move 3 units left. So that's there, units left, and you can draw your graph. And this has a domain of x is greater than or equal to -3, and the range is y greater than or equal to 0. Okay, two things are happening with this function. First, let's graph our parent graph, 0, 0, 1, 1, 4, 2. And inside the parentheses, it's moving it to the right 2 units, and outside it's moving it down 3 units. So every point moves 2 units to the right and 3 down. That's the vertex. 2 units to the right and 3 down. 2 to the right and 3 down. Just like that. Domain would be x greater than or equal to 2. Range is y greater than or equal to -3. If they ask those, I don't know if they will. Solve by graphing in your calculator. So you really have two methods here. I'm not sure which one you like. So I'm going to say there's two methods. So method number 1 and method number 2. I'll show you both and you can decide which one you like. I think a lot of people like it's just solving for x here. So you can set the equation equal to 0, graph in your calculator, and then use trace, the trace command, to find the zeros, of the graph. Let me show you what that would look like. So in this case, you go to graph page. So this just takes one step to solve it. You have to subtract 5. So I'm going to graph that in the calculator. I'm going to say square root of 2x minus 3. Out of there and say minus 5 up from underneath the radical there and minus 5. So I just subtracted 5 from both sides. Graph it. Use trace, so menu, 5, 1. Looks like I need to go to the right. I want to find out the 0 of the graph, so I'm going to keep going to the right until I find the 0. Oops, I think I just passed it. It says 0 at 14. So I know the solution is x equals 14. I would want you to write the x value, not the 0, 14 comma 0. I need the x value. That's the solution. So if I plug in 14, 2 times 14 is 28, minus 3 is 25. Square root of 25 is 5. That works. Check. Not a bad idea to check it. Although on the graph, we don't have to worry about extraneous solutions. It'll only give you the real solutions. The second method, if you choose to use it, and you don't have to, a lot of people like the first method. I think that's the favorite. Just using trace. It's pretty easy. Got to set it equals 0. That's the start. The second method, you're going to graph each. I'll just show it to you. Graph each side of the equation. So what I mean by that is I'm going to graph here. So I'm going to graph square root of 2x plus 3, square root of 2x plus 3. And as my second equation, you tab to open up the entry line. I'm going to graph 5. I'm going to see where those two guys cross. So to find that, you need to use the intersection point tool. So it's a different command, intersection point. So you get that by hitting menu, geometry, points and lines, intersection point. Okay, so I'm going to hit menu, geometry, points and lines, intersection with coordinates. Okay, sorry, menu, geometry, points and lines, intersection point. It says, if you want to know how to use it, you hover over that. It says, click on the green graph, click on the pink graph, and where they cross will be the solution. Let's see. Yeah, they're there. So you have to be able to see the solution. So I had to grab the graph and kind of move it over. So 2x plus 3, so 11. So it really helps to type in the correct equation. So if I look at this one, I think it should be 2x minus 3. That's what the original problem was. So to do that, the correct solution is there. It's going to be 14 comma 5. So the solution, again, is just the x value. I'm not looking for the y value there, just the x value, which is 14. well, it's tougher for me, but it really helps if you just type in the right equation there, which I didn't do. Let's try it again. So using the first method, you might subtract that first. So you get 2 square root of x minus square root of x plus 1 equals 0. So to use that first method, you're just going to go, okay, I'm going to graph that. 2 times square root of x minus square root of x plus 1. And we're trying to find out where it crosses where the zeros are. So menu 5, 1. And looks like there it is. 0.333 repeating. I'm pretty sure that's repeating. And it goes up for forever. So that's the only solution. So x equals 0.3 repeating, or really just 1/3 is the answer there. Using the second method, if we wanted to try it, which again, you might like this method better, is I'm going to type in 2 times the square root of x. And for my second equation, hit tab, square root of x plus 1. Find out where they cross. So you go menu, geometry, points and lines, intersection point. Click in the blue graph, click in the brown graph. And again, you're just looking for the x value. If you want to hit plus, when you're hovering over the top, it'll show you more digits. You can tell it's 0.3 repeating. It is 1/3 when you look at more digits. And I think that is the way you solve those. We have a minute or two extra. Let's go look at the PSAT for today. I think it'd be worth it. So, wow, this is a really long one here. So let's try to get it so you can read this. Okay. So you got this store, it's got this table, it's got an equation right here, which may come in handy. For what number of days X will the total cost of buying the materials and renting the tools from store B be less than or equal to the total cost of buying from store A? So I'd like to find out where those two things are equal. I'm guessing either 6 or 7.3. So if we plug in, say for A, let's just do that here. So let's plug in for A and see what we get. So I'm going to plug into the equation here. So this is going to be M is right here, 750. So Y equals 750 plus W plus K, 15 plus 65, 15 plus 65 times X. So this equation for A, just put Y sub A, just so I know it's A, is 750 plus 80X. Okay, that's one of my equations. Okay, let's do the other one. So B is this one, so that'd be Y equals 600 plus 25 plus 80 times X. So Y equals 600 plus 105X. I really like to find their intersection points. I'd like to see what the graph looks like here. So let's just graph it. This kind of goes along with our lesson today, actually. So 750 plus 80X. Wow, I even got that one in red. It's tie-in right there. This one is 600 plus 105X. This is blue. It's a good day. Oh, it's black. Okay. So, sorry, the y-intercept is way bigger than this, right? So I'm looking for, let's just put 1,000 in there. And the x needs to be a little bigger than that, maybe. No, maybe not. Let me go back up there. I think we need to go higher than 1,000. Let's go 2,000. Ah, I can see where they cross. That's what I want to see, is where they cross. Right, so it looks like the when is store B less than store A? So it looks like until they get to that point, B is less than A. That the blue one is, which is black, and the graph is less than B. So let's find that point of intersection here. So menu, geometry, points and lines, intersection point. So it does come in handy to know how to find that intersection point. And it looks like it says 6, comma, and then that's just some value there, but we don't really care about that value as much as we care about the 6. So I know it's one of these. It's definitely not one of those. So when is B less than A? I would say when X is smaller than or equal to 6. So A would be the correct answer. Wow. It's a pretty tough little PSAT. It took a lot of work and even took an intersection point too. So that's good we learned that.